Alright, so secant to the third is a super famous example. Might want to try to split it up like this. I'm going to try the integral of secant x times secant square x dx. It's legit because I've got 3 secants. It's the same thing as I've got on the top. And now I'm going to spread some of these into a u bucket and some of them into a b bucket. So I'm going to make u is equal to secant x. I'll make dv is equal to secant square x dx. Just got to try something. You got to pull the trigger. It's not the only thing that works. It's just something that works. You could probably try something else on your own, and chances are it'll work. Maybe not, if you're lucky. Alright, so to complete the dictionary here, the differential would be the derivative of secant is secant x tangent x differential of x. The antiderivative of v dv would be v is equal to tangent of x, because when I take the derivative tangent I get secant. That completes my dictionary here. I've got a secant x times a tangent of x minus the integral of a secant x tangent x dx times tangent x. Right? These two pieces, uv, that's here, that's that part right there. And then integral of v du, that's du and v du. V and du. That's what's going here, according to our recipe. This becomes secant x tangent of x minus, I've got a couple of tangents here, secant x tan square. Oh my goodness, what are we going to do now? Well, you could replace the tangent squares with the famous identity here. I'll remind you of something famous. 1 plus a tangent square theta is equal to a secant square theta, right? That means that a tangent square theta can be always exchanged for a secant square theta minus 1. That's an even exchange rate. Back from trig. So this becomes secant x tangent of x minus the integral of secant x times secant square x minus 1 times a dx, which would become, of course, a secant x tangent of x minus the integral of secant to the third x dx plus the integral of secant x and dx after I've distributed the secant. When I distribute it, I get 3 secants here because I got secant square. When I distribute it, I just get a negative secant, but of course I got a minus over here, which would turn into a plus. And lo and behold, you get the boomerang effect again. The boomerang phenomena here, where this whole thing was equal to the secant to the third x dx. This is how the whole thing started, by trying to solve secant to the third, and it is equal to this whole mess, and there it is, the same item that you started off with. What's the perfect remedy here? The simple as basic algebra. You swing it to the other side and collect it here and have 2 of them on this side. That would make 2 of these ones, 2 secant cubes x dx, be worth a secant x tangent of x, that's that piece, plus, of course we've done this one before, ln of, what is that, ln of secant x plus tangent of x, and then slap a 1/2 on both sides on each side, and so you have that the integral of secant to the third x dx is equal to, what is it equal to? Well, on my triumph part, I always like to play music. So that would be equal to 1/2 secant x tangent of x plus ln of secant x plus tangent of x plus a constant. Told you, piece of cake, huh? It's nice. This is a classic one. Has the boomerang effect again. Little trig identities for you. Peace. We'll see you guys here next time. Well, next time we're really going to take it up a notch or two on some nice examples.